Yeah, you found the Hillbilly Voodoo channel. Today we're going to take this excessively long CV axle shaft and make it excessively short. Why? Well, we need it to power our ultimate ATV or Sherp style off-road bug-out buggy, fat truck, whatever the heck you want to call this thing. Stick around, see what type of Hillbilly Voodoo we're going to have to do to make this thing from a long one into a short one. Now, I have cut down a fair amount of axle shafts in my time, but I've never cut down I have cut down CV shafts, but never any this small in diameter. They're usually out of trucks or heavy equipment, stuff like that. So I have disassembled a lot of CV joints, but it's usually in a catastrophic and unrepairable way. So we're going to have to figure out how we can make this 16 inches from the seal mounting surface of the transaxle, this side, to the bearing mounting on this side, which is the outside, the hub where the wheel spins. So we got to chop all this down so that this total length is 16 inches long. Now we got a lot of material to work with here. So the first thing I'm thinking is I'm going to disassemble the plunge side, because that's usually the easiest side to take apart. Because once you take all this stuff, the boot off, the whatever this is, it's the CV joint. It's a plunge style, so it just kind of sort of falls off the end. So that's what I'm assuming. I've never had one of these CV axles out of a PT Cruiser or Neon or anything like that apart. So it's going to be kind of adventure for all of us here. What I'm thinking is to pull this end apart, see if I can get this thing in the lathe without having to disassemble this side, because this side's usually got all the balls and this side usually isn't a whole lot of fun to take apart. So we're going to start with this side and see if this is going to be a viable thing or if we're going to have to come up with some other idea here. Yeah, let's do that. So the first thing that I'm going to try to do is remove these clamps off the CV boots without damaging them too much so that I can actually reuse them when it comes time to put all this back together again. So I don't know how much of this you guys are actually going to be able to see here, but there's little kind of bent over clippy things that hold these pieces down. So if you kind of bend them over, usually you can squeeze this stuff enough that it pops out. I don't know if you guys can see that or not, but I'm not going to do another retake of any type. Not that I would anyways, because my editing sucks, but hopefully I can reuse this when it comes time to put it all back together. Now the inside ones here are usually a little different style. I don't know if you can see that or not, but they kind of pinch together like that. So if you can spread that piece apart, then you can get it usually apart. So I'm gonna stick a punch in there. Why a punch? Because that's what I have sitting here. It a few times. And it spread it apart, and it actually popped it off right away. So hopefully we're going to be able to reuse that one too. Yeah. If not, then I got a little trick that I'll show you to put them back on if and when it comes time to put this stuff back on. So now that we got those off of there, yeah, we're going to try to keep this on the piece of wood here. I'll make a huge mess. So before we pull this end off of here, I'm going to make some measurements to see how much we have to shorten this part. So we're going to go from the seal mounting. You can see where the old seal kind of rubbed on there. I'm going to go from there to bearing is 32 inches. So we're going to write that down somewhere where we're not going to lose it. 32 inches. So we gotta subtract 16, or we gotta make it 16 inches long. So we have we're gonna have to do some math here. Figure out how much of this we're gonna have to cut down to make our total length 16 inches in the end. Now, I don't think we're going to be able to put this dampener back on here because it's going to be too short to have. But then again, we probably won't need that dampener because it will be that much shorter. So yeah, let's pull this piece off of here. Now, there's going to be all kinds of gross, yucky, slimy grease in here that's going to get all over the place. We kind of don't want to lose any of it because, we just don't want to lose any of it. Now, usually there is something retaining these little bearing ball thingies that spin around here. It's usually a clip of some type that holds this on here, which, yep, there's a clip there. Well, let's see what we got here. We got our fancy little hose clamp plier things here. They also work on these clips, so we're going to try this. Guess first you got to kind of be able to see what you're doing, which with all the grease in the way is not really an easy thing. This is by no means a how-to on CV joints. So, yeah. Entertainment purposes only here, guys, because it is what it is. That thing spread apart, I might be able to get it off. Maybe. Come on. Well, that's not really working the way I want it to, so let's see if we can pick it out without stabbing ourselves in the finger. There we go. Always more than one way to do stuff, guys, so if it's not working the first time, then try something else. Unless you really like fighting with stuff all day long and still not getting anywhere. So, got our little clip off of there. Now this little, whatever these things are, I've heard somebody call them a tri-bearing or a plunge bearing. yeah, whatever they're called. It just slides off the end. And grab some more towels here. And we're just going to slide this off the end here and hopefully keep the grease inside here. So the little rubber thing usually sucks all the grease off with it, so you don't really have to lose a whole lot. Or like I say, we're not rebuilding these, we're just disassembling them. So now we have an end that we can stick in the lathe, chuck up, so that we can turn this. Yeah. This thing is held on with the same type of clip that holds on the CV boot. So we're just going to do the same thing here and pull that off. And we'll stick it in the lathe. I'm going to do a few more measurements here, but first we'll stick it in the lathe and figure out how much we're going to have to chop down. Taking that little dampener thing off of there, just to make it easier to measure on our axle length here. So our total length was 32 inches. And the length of the shaft that we need is 16 inches. So I think we're going to, well, it's 32, that's minus 16 was 16, right? 30 minus, yep, that's 16. So we'll take 16 inches, mark that there. Why here? Because that's a good spot to cut it. When we re-weld everything together, there's a lot of rust on there. Anyways, when we re-weld everything together, it should be far enough back from the boot that it doesn't really melt it. And if it does get melty, I guess we can just hose her down with some water and cool her off, but should give us enough room there. It's about an inch, I guess. 16 inches. So we'll stick this in the lathe. What I'm thinking here is we're going to turn this part here down. Well, I don't know, maybe 2 inches, 2 or 3 inches here. Well, let's go 2 inches. Turn it down to about 5/8 of an inch or so. Now we'll go with 5/8. Turn this side down, and then this side we'll drill a hole in it, a 5/8 hole, and then we can slide it together. It'll be kind of like pinned together. Should stay straight that way. If my brain fart is working here properly, then it'll pin it together, it'll be straight. And we can drill holes through and plug weld it. Plus we can weld it around here. And then maybe we'll actually stick another sleeve over the top just to sleeve it. Thicker's always better, right? I don't know if that's true, but kind of works for me. Thicker's better. I would imagine that this is case hardened because my little scribey thing here isn't even making a mark on it. So we're probably gonna have to anneal this shaft. Maybe, yeah, no, it's hardened. So we're gonna have to anneal this shaft before we drill it, unless we really want to break a whole bunch of drill bits and melt them and swear and curse and have temper tantrums, which YouTube kind of doesn't like that. So, well, they don't like the swearing. They seem to love temper tantrums. So let's stick this in the lathe. Let's start turning down our spot here. Maybe we'll make it a little longer. We can always chop it down. We'll turn that down and then see what we're going to have to do to to anneal this end. Yeah, that kind of sounds like a good plan. Let's see if it's actually a good plan or not. I got our shaft set up here in the lathe, and I took a first cut. Now, I don't know what's considered politically correct anymore or allowed anymore, but we're just going to go with this side here is going to be the outie side, and this side here is going to be the innie side. So yeah, we'll have the outie side, and we'll bore a hole in that side. Not here, but down on the other end at their proper length, but this will be the innie side. So I'm gonna bore all this, or turn all this down to, like I said, about 5/8, because I think I got a really nice, good, sharp 5/8 drill bit that when we come to it, we can drill into here. So yeah, we'll turn this down. This will be the outie side, that'll be the innie side. I got my outie part turned here now. Give it just a hair of a taper down to this point. So hopefully when I bore out that end, the innie part, it will tighten up as I push it in. So I'm going to chop it off there, and then we're going to rechuck this end and bore through. But I think, like I said, I'm going to have to anneal it first because this stuff is definitely hardened. Now that I've got this chopped off here, I've reassembled this plunge end of the U-joint, or the CV shaft, back together so that I can, well, more or less verify that I'm not going to be cutting this shaft off too short here. So we'll take our measurement here again from the seal surface to the bearing surface. And right there we have, I'd say about 15 3/4. Let's measure that again. 15 3/4. So maybe we better mark this. That's kind of straight across there. So maybe we better cut it back a little bit farther here. When we get this chopped off and bored out in here, we can always shorten this, right? But it's going to be hard to make it longer, so it's probably better to err on the side of caution here. So if we line that up with that mark now, this is just kind of rough because we do have almost, well, probably 2 inches of plunge in here, so yeah, that's 16 inches there now, and we got, that's pretty much right in the middle. Yeah, so that should work. We'll top it off there, and then we will anneal it because we have to bore the inside of that out, right? Yeah, okay, let's do that. I got the any side bored out there now. Used a 5/8 drill bit, and it's had a little bit of run out on that bit, so it's a little bit sloppy, but not super. Now I'm going to take this out and drill holes through the sides so that when the outie side goes into the any side, I can weld it inside here and then fill this up full of weld. Yeah. Pull that out of there, drill some holes, and stick it back in the lathe here. Push the two pieces together and weld her up. Now, before I get all stupid and carried away here, I'm going to reassemble this stuff just loosely together. Redo my measurements again, make sure that we're pretty close to 16 inches because we got a little bit of wiggle room with the plunge here. So we got our any side and our outie side. Drilled a bunch of holes in here to plug weld through. Now let's jam that together like that. Just loosely. Now we should have, well, to the seal surface, to there we have 15.5. So if we do this, that's about halfway there. Got 16, perfect, I guess. I don't really know where that plunge thing should ride in here, so it's riding right about there. That's the middle. I guess that's probably a good spot for it. Now we're going to stick this thing back in the lathe, try to get it as true as possible here, and then we'll weld it together. Guess while we're at this, we should probably start thinking about what we're going to power this contraption with. Now I wanted to keep the engine small as I possibly can for fuel efficiency and, well, just kind of to see if I can turn these big huge tires with a small motor. So what do I got out there that I can think of off the top of my head? I think I have a couple snowblower engines. We need something with a horizontal shaft. So I know I have at least one snowblower engine out there. I have the motor out of the old fart drift cart. I have a couple of small cc motorcycle engines for like 400, 450 cc. And I have a 1000 cc Gixxer engine. That's kind of over the top with where I want to go for power, because that thing is not easy on fuel at all. But I guess if it comes down to it, then we could probably use that engine if we don't have enough power. But the unfortunate thing around here is, I don't know if in your area or not, but around here I can find all kinds of vertical twin lawn tractor engines. Like, they're falling out of the friggin' trees around here, like free everywhere, all over the place. People with busted up lawnmowers that they don't want to fix anymore. So, but I can't ever seem to find any horizontal this way engines. Now, if I could figure out some way to adapt those vertical engines into a horizontal, I'd be set. Because like I said, there's all kinds of 20 horse, 18 horse, 15 horse motors like that everywhere, all over the place. Electric start, those are great, but can't seem to find any horizontal ones. So, well, that's enough yapping. I'll think about what we're going to power this with. Maybe you guys could leave some comments. What would you like to see it powered with? Remember, it's got to be fuel efficient, because that's part of why we're building a bug out buggy is, yeah, there's not going to be a whole lot of fuel around, and I really don't like spending money on gas. So if I could find a small diesel engine, that would be super awesome, because yeah, you can run that off of anything. But anyways, let's stop yapping. Let's pull this apart, stick it in the lathe. Stuck in there. Ooh. Yeah, it's not a party until somebody gets greased up, eh? So, yeah, let's stick that in the lathe and true it up, weld her together. I got our shaft in the lathe here now, pressed together with the tailstock. Now, in order for me to true this up, I don't have a dial indicator. I'm not quite that fancy yet, so all I did was run up my tool post to the shaft, spun it until it was rubbing all the way around. So that's about as precision as I'm going to get. Now I'm going to weld this up, tack it a few times around here, spin it again, make sure it's as straight as I can get it, and then I will plug weld all these welds. And I cut another piece of pipe that I'm going to slide over the top of here and plug weld that piece of pipe in. I don't want to weld the ends of the pieces of pipe. I just want to leave those open. I don't know why, but getting close to here will melt this, so I don't really want to do that. But some reason I've had luck with sleeving axles, just normal like Toyota axles and stuff like that, and not welding the ends. Every one that I've ever seen break that somebody sleeved it is because they welded the ends of it all the way around. I don't know if it creates a weak spot or a heat spot or whatever, but I've had good luck with just using plug welds all over the place. And yeah, I don't know if that's a good thing or not, but it seems to have worked for me in the past. So keep doing what you always done. You always get what you always got, and if it's working, then hey, I guess that's a good thing. So yeah, enough yapping. I'm gonna go weld this stuff all up here and try and make some gold out of you know what. Shaft's all welded up here now. I took the piece of pipe I had with the other plug holes drilled in it, slid that over, welded that all up, turned it down nice and smooth. Almost looks like you can't even tell that this has been brutally hacked apart. So I'm going to reassemble all this, and we're going to see if it actually fits in there. Now, if I didn't have this lathe, how would I have done this? Well, all the other shafts that I've done in the past might sound really, really ghetto, but all I did was chop them in the center, or chop them somewhere, take a section out of the middle that I needed to take out for every length, bevel each side, slide them together, clamp them in a piece of angle iron, like a 90-degree angle iron, clamp that in there, and just start welding it up until it was all filled with weld. And then I would slide a splint over the top of that. Don't need a lathe to do it. I'm trying to up my fabricating game here, and trying to learn some skills at the same time. If I was a little more skilled and, well, knew what I was doing, I probably would have just tried to cut splines, cut this shaft down to the length I needed, and then tried to make these splines. But I'm really not that gifted yet, and I only have 2 of these CV shafts, so if I screw it up, then it's screwed up. So we did it this way. I knew how to do it this way, just didn't know how to do it in a lathe. So anyways, it's enough of that yapping. Now, I was watching my YouTube channels this morning doing my research, and I realized that, hey, I'm watching a whole bunch of people that I really don't understand what they're saying. Spend half my time trying to decipher, well, I don't even try to decipher anymore. I just watch them and see what they're building. The crazy Ukrainians that build all these weird type of large vehicle ATVs and stuff. And I got to thinking, I'm wondering if maybe there's people out there that don't understand what the hell I'm saying, and they're trying to figure it out and try to build their own, but they're in a different language. It's just kind of a weird thought for you out there. You don't really think that you're watching somebody that's watching you, or you might be watching somebody that's watching you, and yeah, just kind of something to think about. But anyways, that's enough of that. Let's put this back together and see if we made a real thing, or if we just created, yeah, something that isn't going to work. Well, there you go, guys. We got ourselves a CV axle in there. We managed to do it right and made it the right length. I haven't totally bolted it in there, but it's in place and looks like it's going to do what we need it to. And through the magic of YouTube and editing and all that other crap, well, we got 2 of them. Kind of a load off my mind. It was one of those things that was kind of picking away at my brain, telling me that I should get it done before I get any farther on this machine, and realized that I wasn't going to be able to make them short enough, but there you go. We have a Robson drive system. We still have to make our little wheels to drive in between the tires, but first we're going to probably have to modify these tires to the size and tread pattern and all that stuff that we need. So yeah, that's a real thing. So you guys remember to do all that liking, and if you're into this kind of thing, do the subscribing thing, and you'll be able to follow along on this channel. You guys got some ideas about which one of those engines I should use, or maybe some other idea, leave a comment. And thanks for watching. Until next time, use what you got to make what you want. I'll see you guys later.